These are the frequently asked questions for pre-calculus for section 8.2, day 1. And all three of them came from this group of problems. It says in exercises 21 to 36, find an equation in standard form for the ellipse that satisfies the given conditions. Now you'll notice that I have a Cartesian coordinate plane over here to the right. However, you wouldn't have to be that careful with it. You could certainly make a sketch. It's just going to make it easier for me to show you everything. So in 30, it says the minor axis has its endpoints at plus or minus 12, 0. So if we put that minor axis up here, we should be realizing that that is giving us the minor axis. And since the minor axis is horizontal, then the major axis must be vertical. So that is probably the point that most people had trouble when you were accidentally writing a horizontal axis for that one, but let's keep going. I'll just go through the whole thing. Now, this is the minor axis. But you know what? It doesn't matter if they give us a pair of vertices, a pair of covertices, or a pair of foci. Right smack dab in the middle is the center of this ellipse. And so between the negative 12 and the positive 12, obviously we have a center at 0, 0, which is fantastic. So now we know that we want the y squared over the a squared because we had to write this vertical. And it's a matter of figuring out what those numbers are for a and b. Well, we have b, because b is the distance from the center to those covertices, which are actually those endpoints for that minor axis. And that was 12. So we know what that is, and we can go ahead and put a 12 in for b. And that'll give us 144. So the next part would be, how are we going to get A? Well, the only way we're going to get A is if we get more information. So we go back and keep reading, and it says the major axis has a length of 26. So major axis, its entire length is 26. Well, if that's the entire length, then the distance to the center is half of that, and that's A. So half of 26 is 13. So A is 13, and we can go back up here and say, all right, 13 squared is 169. So this one, I am absolutely certain what got you was the introduction of that minor axis that made people think this was horizontal by, going too quickly from the sketch to what they had for the information. So with this, we want to make sure that we're constantly thinking, all right, this is vertical or is this horizontal? Which way do I go with this? And whatever piece of information they give you, graph it and then think about what they've given you, and that'll help you out a lot as far as how you're going to graph that. All right, next up, we have number 33. And number 33 says in exercises 21 to 33, the same directions that we had before, we want to write an equation in standard form for the ellipse that satisfies the given conditions. And apparently I'm not going to get rid of that blue line around the graph. All right, so it says we have foci at 1, -4, and 5, -4, and I'm going to stop reading right there and graph that. So there is a foci, a focus, at 1, -4, and there's another one at 5, -4. Now, that is excellent information because halfway between, it doesn't matter if we're talking about the focus or we're talking about the vertices or we're talking about the covertices, halfway between those 2 points is our center for our ellipse. So with this one, we know it's going to be something -4, so our center something -4, and then all we have to do is find the average of the 2x coordinates because it's just like midpoint. You take 1 plus 5 and get 6, and 6 divided by 2 is 3. So there is the center of this ellipse, which we have to have if we're going to write an equation for it. And then it says the major axis has its endpoints at 0, -4, and that's going to be a vertex. They said that was the major axis. Major axis has its endpoints at 0, -4, and 6, -4. So there's my other vertex right there. Well, that's also great news because that means we can figure out what A is now, because A is the distance from the center to the vertex. It doesn't matter which vertex you use because we're talking about a distance. And since our center was at 3, -4, and then we had a vertex at 0, -4, that is going to be 3 units for A. So now, C, we know that the center is at 3, -4. They gave us the foci, and we can see right in the drawing there, they're 2 units away. Now, go back to the information. Foci, 1, -4, 5, -4, major axis endpoints at 0, -4, and 6, -4, and you realize we are going to have to find B using the information that we have about A and C. So C squared equals A squared minus B squared when you're talking about an ellipse. So 2 squared will equal 3 squared minus B squared. Well, that's 4, and this is 9. And if we subtract that, we're going to get a -5 equals -B squared. Well, that means 5 is B squared, and that makes B equal to the square root of 5. And we could put the plus or minus piece on there, but you know what? We're not going to need it. We're supposed to write an equation for this. So now we take a look at what we had up there. And obviously the foci, that's the focal axis that they're on. So this one is horizontal. So we're going to need x minus h squared over a squared plus y minus k squared over b squared to equal 1. And let's put in what we know. We know our center, and the center is always h and k. So x minus 3, the quantity squared over. We know that a is 3, so a squared is 9. We know that our k value is -4, so y minus a -4 will be y plus 4, the quantity squared, all over. And then our b squared, we really could have stopped at that. If we're not graphing it, we didn't need to know that b is the square root of 5. We needed to know b squared. So there goes our 5. And there it is. So now we have an ellipse centered at 3, -4, and we have our values for a at 3 and our value for b at the square root of 5, because a squared is 9 and b squared is 5. So that one is set. Again, the sketch always helps you think through all the little pieces that you need when you're writing these. So number 35, same instructions, writing it in standard form. We have a major axis with endpoints at 3, -7. We'll graph those vertices. We have this 3, -7 and a 3, 3. And that tells us a couple of things. First, that of course gives us the fact that that is the major axis, and that tells us that this is going to be a vertical ellipse. And halfway between those 2 points is where our center is located at. So obviously it's going to be 3 something. We just need to figure out the midpoint halfway between -7 and 3. So -7 plus 3 is -4, divided by 2 will be -2. So our new center is at 3, -2. And right now we can find A because we know how many units it is away. I mean, if we go from 3, -2 to 3, -7, that's a difference of 5 units. So there is our length from the center to the vertex. And then we have a minor axis that's a length of 6. So the minor axis has to go horizontal, and because the minor axis is a length of 6, that means B is 6 divided by 2, which is 3. So from our center, we would go 3 units in each direction for the covertices. But we didn't have to graph this one. You know, we just needed to know, is this horizontal, is it vertical, and be able to get the pieces of information that we need. And that would be the center and A and B. And we already have those. So we can go ahead and use that information to write it, noting that we have to be careful about our positioning here. Because we have to have a squared below the y coordinates for our center there. So it'll be y minus a -2, which is y plus 2 squared over 5 squared is 25, plus x minus 3 squared, don't forget it's always h, then k, over 3 squared, which is 9. So the graphing part again could just be a sketch. It doesn't have to be anything fancy as you go through it. But those are the 3 that you had asked for.